Okay, so for my physics presentation that I'll be making here, I'm going to cover the topic of waves. I'm going to be covering from what they are to the different types of waves to how we interact with them on a daily schedule. I'm going to start off by labeling the parts of a wave, kind of how they look. So here we have pretty much like a diagram of a wave. I'm gonna describe a few points. Okay, so if you get the distance, okay, so I'm gonna label at the point where these they're kind of like hills. At the point where they're at their height, the height is called the crest, right? And then the bottoms, they're called troughs. So it's pretty much the crest is the top, the trough is the bottom. The points in between, where they interact with this point, this line where we call equilibrium, pretty much the middle. These points right here, these are called nodes. These are called nodes. Another important thing that you might want to know about waves is right here, this is called the amplitude. It's pretty much how tall the wave is. And so this is the amplitude right there. Another very important thing that you might want to know is the direction of travel. So yeah, like at what direction the wave is moving. And finally, the wavelength. So it's pretty much how long it's a crest and a trough and 3 nodes. So it's pretty much like up, like this part, and up, like where it repeats. And that's the wavelength. So as you can see in this thing, it kind of it oscillates. It's called oscillation when it's like when something's turning on and off, on and off, on and off, or going up and down, up and down, up and down. That's oscillation. So what a wave is, it's an oscillation accompanied by a transfer of energy. So it's an oscillation of energy, pretty much. So some waves, not all, they need to travel through a medium. I'll get more into that later. But as they travel, as they're moving, everything that moves, I mean, it has a velocity. So you're going to want to know the velocity of a wave. For this theoretical wave, I don't know, I'm just going to say it's 10 meters per second. That's the rate at which this wave is moving through this medium, if there is a medium. Another thing you're going to want to know is the wavelength. So pretty much, here's velocity. The wavelength, we're going to go ahead and say it's, let's go say 0.5 meters, just to keep it somewhat simple. So the wavelength is going to be like 0.5 meters. Another important thing you want to know is the frequency. Frequency, we're going to measure that in hertz. What hertz is, I'm just going to draw it right here, hertz. What that is, it's a unit of like per second time. So if, let's say you throw a ball to your friend, let's say you're really fast at throwing balls, let's say you throw it like 10 times in a second. That means you were throwing it at a rate of 10 hertz. It's 10 times per second. It's like a per second unit. So let's just say that that's the frequency of a wave. That's frequency, it's like how often it happens. Like, so the frequency is going to be, let's just call it, let's say it's a pretty fast wave. Let's say it's like 100 hertz. So those are some of the values that you're going to want to know for a wave. And there's a nice little convenient equation, which, I mean, you could manipulate it to mean different things, but let's go ahead and say its velocity equals the frequency. That's that little signal, velocity, right? And that's the symbol for a wavelength. So it's the velocity is equal to the wavelength times the frequency of a wave. So if you know two of those values, you could solve for the other one by manipulating the equation if you need to. Okay, so what I drew here kind of shows a transverse wave. So what this means is that the direction of travel of energy is like perpendicular to like how the wave's moving. So so yeah, it looks like this, right? Whatever. That's a little ugly, but it looks like that. Another type of wave, is called longitudinal. Longitudinal. Oh, I can't spell. Longitudinal. So it's pretty much going to be, it's the same thing where there's high energy and low energy, like that. It's just going to be, there's just like points with really high energy, points with really low energy. So it's very similar. It's just it's now parallel, like how the particles are moving. It's just moving with the direction of where like the energy is moving. Some other waves, some other cool stuff about waves, some other categorizations of waves, is the difference between electromagnetic waves, like EG waves, and mechanical waves. And mechanical waves. Electromagnetic waves versus mechanical waves. They're two different things. Before I describe the difference between the two, I'm going to kind of give examples of each. And just to start off with that, let's see. With electromagnetic waves, there's this really handy spectrum that people like to draw, and I'll just draw it here. So it pretty much goes by wavelengths, with the greater wavelengths on this side, so like let's go 10 to the 4th over here, meters. So they're really big wavelengths. And on this side, let's go 10 to the negative 14 meters. Really small and unimaginably small wavelengths. So in there, there's different energies. I mean, they're different wavelengths, so they carry different amount of energies. So over here on this like really energetic, high frequency side, over here you can see this really high frequency side, we're gonna have gamma rays. You know, the type you hear about with radiation, and X-rays over here too. These really high energy waves that could potentially be harming if they're ionizing. So that's some bad radiation, which is just, they're the waves, and they could be harmful. We could move, if you move a little bit lower, you get UV rays, which you've probably also heard about. It's ultraviolet. So when you sunscreen, it protects you from these harmful UV rays. And this little section right here is what we call like the visible light spectrum. It's just a tiny little section, and it's kind of what it sounds like. It's visible light. So it goes from, you know, Roy G. Biv. Red starts over here, and all the way over here it's violet. So, so we got like different values of how the frequency of the waves, the wavelength. I mean, the wavelength of the waves. They give you different colors. So yeah, you know the alphabet. The rainbow, you know, moves down that way. Infrared is on this side over here. Infrared light, you know, TVs, I believe, use these. Radar, different types of light. These they get to longer and longer wavelengths. You know, FM radio, TV. So then there's these greater wavelengths with these different. So they change like their characteristics and how they behave based on their wavelength. These electromagnetic waves. You need to keep in mind that these are electromagnetic waves. Let's see. So these are electromagnetic waves. Oh, let me mention something really cool about electromagnetic waves. Okay, so if you have a microwave, let's just draw a little microwave in here. Whatever. If you have a microwave and you put your phone in there, if you try and call it with some sort of internet service, like Skype or like FaceTime or something like that, something that you use to call with using Wi-Fi, you're gonna find that the call probably won't go through, and that's because the microwave is made so that microwaves don't get out and possibly harm like, the people outside. And the wavelength for like these, usually a Wi-Fi, it's 2.4 gigahertz. So it's a really short it's a really high frequency. And that's really close to what microwaves are, so it blocks it off. But if you use like normal cell phone calling, they have longer wavelengths. They have so what they're able to do is they have a greater likelihood of actually being able to penetrate the microwave and your call will go through. So I mean, if you ever need to, silence your phone quickly, just throw it in the microwave, and you probably won't get anything. So that's some stuff about electromagnetic waves. Mechanical waves are really similar. Probably the most popular and like mentioned mechanical wave is sound waves. You've probably heard of them. No pun intended. But sound waves. So I'm just going to draw a quick wave diagram just to explain a few things. So the amplitude of the wave, that's going to control how loud something is. So the greater the amplitude, the louder it is. It's pretty self-explanatory. Another thing, the frequency, as in like how short or how frequent the wave is, the frequency. The lower frequencies have deeper, lower sounds, and then the higher frequencies have like high-pitched sounds. That's called the pitch. Changing the frequency changes the pitch. Changing the amplitude changes the loudness. So yes, here we have like a higher frequency, so it makes a much screechier sound. The older you get, the less high frequency sounds you could hear. So as you age, you lose your ability to listen to some of these sounds. So what's the difference between these electromagnetic waves and mechanical waves? Let's see. The biggest difference, the notable one, is that the fact that mechanical waves need a medium to travel through. So what that means is that they need something to like transfer their energy through. So like air, sound, you need air to have it travel through like a certain area. So if you're in outer space, the vacuum of space, there's no like air for it to travel, so sound will really travel through space. Electromagnetic waves, on the other hand, do not need a medium to travel. That's why we could see the sun. Even though it's passing through space, it doesn't need a medium to travel, so we could see the light from the sun. It could travel through a vacuum. It doesn't really need it. It doesn't need to travel through a vacuum. It could travel through a vacuum, but I mean, it could also travel through a medium, unless it can't. But those are just some of the different types of waves. That's gonna wrap up this kind of long presentation, just about waves and how they behave and how you might how they're around us, from like Wi-Fi to the music you're listening to, which just changes frequencies a lot to make different sounds. FM radio, AM radio, TV, all these different signals, their energy transfers through waves. Even so when you call somebody, the phone changes your sound waves into electrical signals, and then that travels through and it gets converted into a speaker. So it's waves are all around us, always affecting our lives, and yeah, those are waves. Thank you. See ya.